Now, in this video, we are going to take up one more problem on a steel tie rod, problem number 19. It reads as a steel tie rod 50 mm in diameter and 5 meter long is subjected to a pull of 100 kilonewton. To what length the bar should be bored centrally so that the total extension will increase by 20% under the same pull. The bore being 25 mm diameter, take E equals 2 into 10 to the power of 5 Newton per mm square. So a steel tie rod of 50 mm diameter. So this is the rod of 50 mm diameter having 5 meter long. So from here to here you have a 5 meter long. Is subjected to a pull, that is axial pull, that is the tensile load is of 100 kilonewton. To what length bar should be bored centrally? So centrally to what length, that is L, should be bored centrally so that the total extension will increase by 20%. So 20 by 120 by 100 under the same pull. So whatever that pull you will going to be applied, that will going to be the same pull. The bore being 25 mm diameter. So this bore having the diameter, which is E is equal to 2 into 10 to the power of 5 Newton per mm square. So this can be considered as the two sections. When is the bore, so you take the cross-sectional bar without having the bore, and also we have to consider the cross-section with the bore also. So the rod without the bore, which first we are going to consider. So what is the extension of the rod? That is delta L is given by P into L by A into E. So what is that P? P is nothing but 100 kilonewton. So 100 into 10 to the power of 3. Then what is the length of the rod? The length of the rod is 5 meters, so 5000. But what is the area of cross section? Area of cross section is pi by 4 into 50 square. That is the diameter of the bar will going to be 50 square into what is the Young's modulus of the material is 2 into 10 to the power of 5. Substitute all these values here, and then on simplification you will going to get that as 1.27324 mm. So this will going to be the total extension of the rod without considering the bore. So then what we need to do is we need to consider a rod with bore. So when you are considering the rod with the bore, let L be the length of the bore. So that means we don't know to what length we need to bore, and delta be the total extension of the rod. So what is the total extension of the rod? Delta L will be equal to, that is, he has given the 20% more than the extension, total extension. So that will be equal to 1.27324 into 120 by 100. 20% more or 20% greater. So 120 by 100. So you will going to get the total extension of the rod will going to be 1.528. So also what we know, the delta L will be equal to extension of the unbored section plus extension of the bored section. So what is the extension of the unbored section? 5000 minus L. So 1.528 will be equal to 100 into 10 to the power of 3. That is, again you substitute this this formula here, 100 into 10 to the power of 3 into what is the extension of the unbored section, which is 5000 minus L divided by pi into 50 square into 2 into 10 to the power of 5 by 4. So plus extension of the bored section, it will going to be like a hollow cylinder. So that is again 100 into 10 to the power of 3 into the length will going to be L divided by pi by 4 into 50 square minus 25 square into 2 into 10 to the power of 5. So in all the parameters are known except the L. So on simplification, it will going to be, so when you simplify that, you will going to get it as 2.5465 into 10 to the power of minus 4 into 5000 minus L plus, again you simplify this, you're going to get it as 3.3953 into 10 to the power of minus 4 into L, that is equal to 1.528. Therefore, the length of the board section L will be equal to 3000 mm, which is equal to 3 meters. So this is how you will be able to calculate the length of the board section. Now, we'll continue with the one more problem, that problem number 20. Find the total elongation and the maximum stress in the material of the bar, which is shown in the figure, under an axial load of 20 kilonewton. Take E is equal to 200 giganewton per meter square. So here you can see there is a bar of 25 mm diameter of a length of 400 and having a taper bar which is from reducing from 25 to 15 for a length of 400. Then you have a diameter 15, a solid bar of 400 mm length, having the same axial pull of 20 kilonewton. So he says find the total elongation of the bar. So what will going to be the total elongation, which will be delta L will be equal to delta L1. So that is the extension of this bar section plus delta L2, extension of the tapering bar of the cross section varying from 25 to 15, and delta L3, the extension for the bar of diameter 15 over a length of 400. So you're going to substitute these things, that is delta L1 will going to be uniform bar. So that is P into L by A into A. Since for the section 1, since you have the same axial load P, so P into L1 is the length of the section at 1, then A1 area of cross section at A1 and material is same into E, plus since it is the uniform tapering bar or tapering rod having from diameter 25 to 15, so that will be equal to plus 4 into P into L, P into L2 divided by pi into E into D1 into D2 plus P into L3 by A3 into E. So now we are going to substitute these values. What is P? P is nothing but 20 kilonewton. So you convert the 20 kilonewton into Newton, which will be 20 into 10 to the power of 3 into length of this section. But the section 1, you are considering this as section 1, which is equal to 400 divided by area by pi by 4 into 25 square. It should be 25 square here into E is 200 giganewton per meter square, which will going to be 200 into 10 to the power of 3. Then you have plus 4 into P is again 20 into 10 to the power of 3 into L2 is 400 divided by pi by 4, that is pi into E is 200 into 10 to the power of 3 into 25 is D1 and 15 is D2, and it should be 15 here, plus P into, that is 200 into 10 to the power of 3 into L3 is 400 divided by pi into 15 square by 4 into 200 into 10 to the power of 3. So on simplification, what you will going to get it as 0.0815. So this will going to be the total elongation of the bar. And also he will going to ask you to find the maximum stress. So that is equal to 0.0815 for the first one, plus for the second one it will be plus 0.1358. So on simplification of this, the third one will going to be 0.2264. So what will going to be the total extension? The total extension will going to be 0.4437 mm. So what will going to be the maximum stress in the bar? The maximum stress in the bar will going to be where you have the least cross-sectional area. The least cross-sectional area what we have is the 15. So applied load is P, which is 20 into 10 to the power of 3 by least cross-sectional area is pi by 4 into 15 square, because the diameter is minimum at this point. So on simplification, you will going to get it as 113.2 Newton per mm square. Therefore, from the given problem, he says that what the total elongation will going to be 0.4437 mm, and also the maximum stress in the material is 113.2 Newton per mm square. This is how you will be able to solve this problem. If you find this video is useful, then please subscribe to my channel. Thank you.